as anybody who beats the drum of Mars exploration and wanting humans to be present there, as they all say, that there's only so much that a robot can do, and there's only so much experimentation that can be done robotically. And effectively, all of these images that are being sent back by the robots and all of the measurements that are being taken through the instruments on the rovers and such, they're all just kind of teasers for what we could actually possibly do, because no better exploration can be done than by a human on the surface of Mars, to the extent that we can actually respond more readily to the environment that we're presented with. We can more actively and more intelligently select the types of experimentation and the types of investigation that we can do at any given time on the Martian surface. There are a number of reasons to go, and a number of reasons that are actively being promoted within the industry, both to government organizations as well as to the general public. Certainly, number one at the top of the list, because it is a commercially viable reason to go, is just the fact that there are resources that we as Canadians, yes, but we as humans on Earth can readily exploit and are finding ourselves quickly running out of here on Earth. And there are even other resources that aren't available here on Earth, that are more easily obtainable on the surface of Mars, that we can use for furthering our technology and furthering our better living here on Earth. We are quickly overpopulating the Earth, and so besides curtailing population growth, the other option that many people that favor the idea of space exploration is the idea that we can expand beyond the Earth's atmosphere to first land on the Moon, but then to ultimately go on to Mars. And Mars is the key proponent for human exploration and human development, because it is the closest in relation to Earth in terms of its atmosphere, in terms of its size, and potentially in terms of its geological history, so that we as humans could potentially benefit from actually being on Mars without radically, or too radically anyway, changing the face of Mars, or it is a much more achievable step to change the face of Mars than it is, for example, Mercury or Venus or any of these other planets. So certainly Mars stands as the next best place for us as humans to expand upon.
My topic is to talk about some of the physiological and perhaps psychological limitations of human explorations in Mars. Now, before I do that, I think that I need to give you some background information to put things into perspective. I often tell my students is that all organisms, as well as human beings, of course, we are conceived under 1G. We are born under 1G. 1G is gravity. The gravitational acceleration is 9.8 meters per second square, and we named it as 1G. When you pull an aircraft around, we can experience more than 1G. We call it 2G, 3G, and 4G, and so forth. And then we have microgravity. Well, due to the fact that we're conceived and born under 1G, our anatomical system, the physiological system, as well as the biomechanical system of our body, are designed to adapt to 1G environment. So I can say that we are hardwired to do 1G. And that we react appropriately to 1G because of our development. So therefore, inevitably, if we are now being put into an altered gravitational inertial environment, such as less than 1G, okay, it's no surprise that we will have physiological changes. As well, we have to learn to adapt to this new environment. Let me set a scenario for you. In order to go to Mars, the most common postulate is that it will take between 1 to 3 years. And my guess is it will take 3 years for sure. 1 year to go there. You want to spend, since you take 1 year to go there, might as well spend some time there. And it will probably take you 1 year to come back, provided there's nothing untoward happen. Now, the real issue is that whether humans can adapt to Mars gravity, which is 0.38 G, approximately 1/3. And this is after the microgravity exposure in the interplanetary voyage that you go there. So you have a long duration of microgravity, about 0.0003 G or something like that in suborbit. And then you readapt to about 1/3 of gravity. And then, of course, you're going to have to come back. Okay? Can you then readapt to the microgravity on your way coming back after the extended period on Mars? Every time your heart contracts, you have a certain amount of blood that's being pumped out in your aorta. That output is substantially decreased. And at the same time, you have a decrease in your vascular resistance. What I meant is that within your lower extremity, especially, your artery system have a contraction mechanism that will vasoconstrict the blood vessel to prevent blood from pooling at your legs. Now, a few words about the musculoskeletal changes. You have bone loss about 1 to 3% per month while you're in space. Muscle atrophy will progress in about 5% per month. Your oxygen consumption are reduced by 25% after a few weeks in space. Now think about this. We are talking about Mars mission, right? We're talking about like a 3-month thing here. If these figures are simply extrapolated then, I think future human mission to Mars will be seriously jeopardized, and crews will be they will find that they will cross the threshold that the bone loss and the muscle atrophy will not be able to come back.
So given society's limited financial resources, and I can't stress that enough, what we're talking about are finite resources and how are we going to spend those resources, the argument for space travel must be nested in more robust series of rationales that consider other desirable or even innate human values. So 2, and this is a Mars Society projected benefit. Quote, a cooperative international exploration of Mars would serve as an example of how the same joint action could work on Earth in other ventures. So we have 2 values to consider here, cooperation and exploration, both postulated as goods in and of themselves. Okay, so we have already many examples of meaningful and inspirational international cooperation. In sports, we have the Olympics. In culture, we have biennials. In diplomacy, we have the European Economic Community. We have nuclear non-proliferation pacts. And we have examples of cooperation in space. We have the Skylab from when I was growing up, and the Mir Space Station and others. So while certainly laudatory, creating a way for nations to work together needn't cost tens, perhaps hundreds of billions of dollars, particularly when the scientific goals being sought may in fact not be achievable. So let's look at exploration. This motive is as old as life itself, and I expect equally uncontestable. But as we know from studying our own history, the dominant regimes control the means of exploration and exploit those discoveries to their own ends. Currently, very few nations have ventured into space. Given the magnitude of resources and technological sophistication required to do so, it seems unlikely that all nations would be able to meaningfully participate in this international venture or benefit from it. So, clearly a fair process would have to be developed for commercializing or claiming property in space so that any good that may be accrued through exploration and research benefits all humankind. And what might those benefits look like? Well, that brings us to perhaps the most potent argument for racing to space, racing to Mars rather, and that's to improve our understanding of the universe and our place in it.